Assalamualaikum warahmatullahi wabarakatuh. We are from
Group 3.
So in this video, we're gonna talk about how to solve pattern of number and differentiation of calculus.
And there will be a little bit of explanation about this problem.
3, 2, 1, jump!
Hi guys, my name is Tao and this is my friends.
Hi, I am Masa.
So guys, in this video we're gonna talk about problem solving about two topics. The first one is pattern of number and the second one is differentiation. But before that, I'm gonna give you some information about STEM.
So let's discuss together.
So what is STEM? STEM is an acronym about science, technology, engineering, and mathematics. So STEM is a breakthrough in education that will combine four subjects including science, technology, engineering, and mathematics, of course, to make a better quality in education. Next, to the first topic, pattern of number. Guys, did you know that number have a pattern? And the pattern not only one, so they are type of numbers pattern. For the general, we have odd number pattern. It consists of odd numbers. Next, we have even number pattern. It consists of even numbers. Next, we have triangular number pattern. This pattern consists of numbers that can we create into a triangular shape. And the next, we have square number pattern. In this pattern, it consists of numbers that can we create into a square shape.
Masakopedia.
So guys, in addition to this general pattern before, we can see number patterns from events in daily life. For example, the pattern of IV fluid drips and the pattern of vehicle oil drips.
Interesting, right?
Of course, Musa, it's interesting. So guys, after this, there are problem solving about pattern of number with STEM nuance to give you some better understanding about STEM context.
Okay guys, now I will talk about the first problem about number pattern. So the problem is oil lubricant is an engine. It's the process of providing a layer of oil on the moving parts of the engine, such as the piston and cylinder. To reduce friction and heat generated by their movement, oil also helps prevent wear, corrosion, and dirt built up in the engine. With good oil lubrication, the engine can operate more efficiently and last longer. In a workshop, there are two cars with oil leaks. Car A leaks 40 milliliters in a minute, while car B leaks 10 milliliters in a minute. But due to a worsening problem with car B, the amount of oil that comes out will double every minute. After some time, the total amount of oil that leaked from car A and B was checked, and it was found that car A leaked 280 milliliters of oil. What was the total amount of oil that leaked from car B at the same time? From this question, we can take some information. Like in here, car A leaks 40 milliliters oil in a minute, and car B leaks 10 milliliters in a minute. But car B will double every minute. And after some time, car A leaks 280 milliliters. So how to find how much oil that leaks from car B at the same time? We can solve it by using number pattern. So this is the solving. To find how much oil is leaking for car B, we need to know how long times the oil has been leaking. The duration of oil leak is the total amount of oil leak on car A divided by amount of oil leak on car A in a minute. We know that sum of oil leak on car A is 280 milliliters per and oil leaks from car A is 40 milliliters in a minute. So by dividing 280 over 40, we can get that oil has been leaked in 7 minutes. Now we know that oil has been leaked for 7 minutes. To find the amount of oil that leaked for car B, we can solve using this number pattern. We know in the first minute, the oil will leak 10 milliliters and it will double every minute. So the next 1 minute, it will leak 20 milliliters. Next 1 minute is 40 milliliters up to 640 milliliters in 7 minutes. So the total amount of oil that leaks from car B is 10 plus 20 plus 40 plus 80 plus 160 plus 320 plus 640. So the total amount of oil that leak is 1270 milliliters or 1.27 liters. So I hope you can understand about this problem solving, guys. Thank you.
Hi guys, I'm back. So the next part is differentiation.
Hi, Mosa Betsu. Did you know?
So guys, every time you get in your car, you witness differentiation percent. Your speed is the first derivative of your position. And when you step on the accelerator or the brake, accelerating or decelerating, you experience a second derivative. If a function gives the position of something as a function of time, the first derivative gives its velocity, and the second derivative gives its acceleration. So, you differentiate position to get velocity, and you differentiate velocity to get acceleration. For the next part, there is problem solving about topic differentiation.
Okay, thank you Mosa and Devi for the explanation about differentiation calculus. And now I have a problem. Did you see the picture of the car? Yeah, this car is a Pandawa Evolution 3, which is an electric car made by 6 students of the Faculty of Engineering from UNES. Wow, that's amazing, right? This car has become the best electric car in the electric car competition in Okinawa, Japan in 2016. Because Pandawa car is an electric car, so it's more environmentally friendly because it doesn't emit waste gas emission. So this is in accordance with UNES, which has a conservation perspective. In general, the way electric cars work is by converting the electrical power in the battery into kinetic energy to move the wheels of the car. If the kinetic energy make the car has the speed is Vt that equal to t cube minus 14t square minus 20t plus 250 meter per second, with t is the time in second. So, at which second will the acceleration of the Pandawa car be constant? To solve this problem, can use the concept of derivative. So, let's look at problem solving about this problem. Okay, for the problem solving, first, we must write the given of the problem. Given that Vt equal to t cube minus 14t square minus 20t plus 250 meter per second, and the asked is at which second the acceleration be constant. That's the asked. So for answer this problem, we can use the derivative concept. We know that the derivative of velocity or speed is acceleration, right? So if we want to find the acceleration of the car, then we have to derive the velocity. Okay, let A be the acceleration of the car. So we get A that equal to dv over dt that equal to 0. Why 0? Because we must to find the critical value of a. So we must to equal the a equal to 0. We know that the a is the derivative of v, so we must to derive v. With the power rule, we get that t cubed, the derivative of t cubed is 3t power 3 minus 1, and for the 14t square that equal to 2 times 14t power 2 minus 1, and for 20t we know that the t is the power 1, so 20 times t1 minus 1, and because 250 is a constant, so the derivative is 0. So we get the derivative of v is 3t squared minus 28t minus 20 that equal to 0. We will find the factorize of 3t squared minus 28t minus 20 that equal to 0, and we get 3t plus 2 times t minus 10 that equal to 0. So for the left, 3t plus 2 that equal to 0, we get t is negative 2 over 3. And for the right, we get the t minus 10 that equal to 0, so t that equal to 10. And we get the t. Okay guys, do you remember about t? Nah, t is time, right? So t must be greater than or equal to 0. So t is not the negative. So we will choose the t is 10. Because we have found the t that t equal to 10, so it means that the acceleration of Pandawa car will be constant at the time of the 10th second. Okay, this is the solution. You can rotate your handphone to see it clearly. Okay, it's enough for me. And Mosa, I'm done. Bye-bye.
So guys, that's all about our discussion today. See you in the next video.